Natural language processing, also known as NLP, is a subset of AI technology that works with the communication of humans and computers through the use of simple language. Its eventual aim is to encounter, comprehend, and create a sense of human language. In this session, we will examine Textblob, a popular library for linguistic data preparation, as well as the fundamentals of NLP such as stopword, lemmatization, and why and how we can clean text data. We will also go through the many methods of text data processing. Along with it, we will also look into the features that TextBlob offers as well as address a sentiment analysis use case with TextBlob and Python. So put on your thinking hats and let's get started with this session on TextBlob. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Have you ever given it a thought how Gmail or Outlook or any mailing services segregates your mail into a spam or a normal mail? Similarly, suppose you opened a website which is written in Russian or in a French, and since you don't know the language Russian or French, so what Google Chrome or Mozilla Firefox or Safari or various other browsers, what service they do provide? They provide a service to translate the entire language into English or some language which you knows. Similarly, we have also seen that in YouTube, it provides a subtitle to the videos. All these are products of NLP. NLP stands for Natural Language Processing, which is the field of artificial intelligence which deals with textual data as well as new audio data. So we human on an everyday, we write things on paper, we do write emails, we also chat on WhatsApp, we also write our opinions or things like that on Reddit. Similarly, we do write things on Facebook, Twitter, LinkedIn, and by doing these things, we create huge amount of data. This data may be structured or may not be structured, but we create huge amount of data. So how can we get the information or how can we extract the information from those data? So to do so, we have a savior, that is natural language processing. So today in this course, we are going to discuss about one of the library known as Textblob, which used to do all the pre-processing and various other things and make natural language processing easy for us. So today in this course, first we will be covering what is NLP. Then we will see some of the concepts of NLP and we'll do a recap of natural language processing. Then we will look into that what is Textblob. After that, we will be looking into that what are the facilities which we get with the help of Textblob. Then we will be doing a sentiment analysis using Textblob. So I'm excited. I hope you all are also excited. So let's get started. So, what is NLP? Before we go and discuss the functionalities or the properties of natural language processing, let's discuss what is natural language processing. So, natural language processing is a process of manipulation of natural language. What is natural language? Human language, that is English, Hindi, French, Tamil, Kannada, Russian, any other language in the form of either it can be audio or it can be text using some software or some tools. So it is an automated process to extract required information from the data by applying machine learning operations. So what do? We get the raw data, that is raw text data. On top of that, we do the processing. So after doing that processing, we get the clean data. So we get clean data. On top of that, we apply machine learning or deep learning or any other things like transformers, and we can apply uh, other technologies, and from those technologies we get information. So some of the examples of NLP, or we can say what are the operations we can do with the NLP, like POS tagging, that is parts of speech tagging. So whether in a sentence the word is a noun or it's a pronoun or it's verb or it's adjective. So these kind of a thing, all the parts of speech we can extract with the help of POS tagging. Similarly, there is a function of NER. So let's suppose we write Ram is a good boy. Okay. So what we are doing? So here Ram is an entity. So Ram is a person. Good is like its feature, or we can say property. Boy is a gender. So all sort of information we can extract with the help of name entity recognition. Then comes speech recognition. You have seen that we have mobiles. In mobiles we do have features like the mobile will close or the mobile will open once you speak. So what it does, once you speak, it checks the pitch or the amplitude of the audio, and based on that it orders the mobile that yes, the person is right, and your mobile gets unblocked, or it gets locked. So based on the things which you provide, the command you provide, it acts the same. Similarly, it also helps in doing the language translation. So we have seen the examples of Google Translation, in which suppose you know English and you want to talk to some person who is French. So and that person is not knowing English. So it's a very difficult task for both of you to communicate. So in order to communicate, what you can do, you guys can translate each other's language with the help of Google Translate or any other software, and then you can fill the gap between the two. Similarly, sentiment analysis. Sentiment analysis is one of the most important, and it's very widely used use case in terms of you can say in any organization. For example, let's take the example of there is a retail company. Okay, so there is a sorry, there is a retail. Okay, so in that retail portal, people used to buy things. Okay, so when they buy, they provide review. So based on that, those reviews, like whether this review is a positive review, it's a neutral review, or it's a negative review. Okay, how can you know that? So let's suppose that your retail organization on an average in a month they get around 20 million reviews. So will you hire people and ask them to go one by one? No, it's a very difficult task to do, as well as it's time consuming. It's money wise also it's a burden for the organization. So what they can do, they can use the sentiment analysis. So what sentiment analysis will do? Sentiment analysis will uh, uh, do the text analysis. It will get the features from the text. Based on it, it can say that whether the sentence is a positive sentence, it's a negative sentence, or it's a neutral sentence. For example, he is a good boy. Okay, so it's a positive. Let's suppose uh, Bella is a annoying but very good cat. Okay, so what kind of sentence is this? It's a positive one also, and it's a negative one also. So either we can say that it's a negative, or we can say that it's a neutral. Since, okay, we know that cat is annoying, but it is very good cat. Good means what we can say, the cat, whatever their they command, give command to it, she follows all those commands. Okay, so by this they can say that, we can say that it's a neutral sentence. Okay, so what are the things we can do with the natural language processing, or the basic data processing in natural language processing? So, before we go and discuss that, data can be of two types. So, data can be either it can be structured, or it can be unstructured. So, what do I mean by structured? So, if your data is something like, it's for example, everything, uh, hey everyone, good morning, how are you? Let's say. So we can say that there are three sentences, and all the sentences are nicely structured. On the same side, let's suppose there is a data in which, hey, it's 20th August 2021. Okay, then they are saying, hey everyone. So this is one sentence, this is another sentence. Then good, let's say, sorry, let me erase it. Yes, so good 20 dot dot CST. Then there is next sentence, morning, how are you? So if you see, there is a hey, then there is a date, then there is everyone in the next sentence. Good, then there is a sentence, CST, that is reflecting time, this is reflecting date. Okay, and then these two sentences are together. Okay, so what we can say, that if this kind of thing happens, then we need to process those data, or we need to remove the redundancy, or remove the unwanted text from that data. Okay, so this is an example of unstructured data, and this is an example of structured data. So let me remove all. Yeah, so now unstructured data makes NLP task difficult, because most of your time will spend into pre-processing the data. So what are the basic data pre-processing steps we can perform in natural language processing? We can do text normalization, stopword removal, punctuation removal, email or any URL removal, number removal, white space removal, normalizing text to an ASCII label from, let's say, UNI 18, okay, UTF 18, sorry, UTF 18 to ASCII, then stemming, lemmatization, and text vectorization. So now let's see each operations one by one. So what is text normalization? So I'll just write normalization. Okay. So let's suppose you have written two sentences. Hey Ramesh and hey Ramesh. Okay. So for a human, it is easy for us to identify that both are same. But when it comes to machine, what machine will do? Machine will take it as a 1. Then it will see that R is capital, AMESHR lower. Similarly, on the second line, it will see that, okay, A and then Ramesh, all are in lowercase. So what it will consider? It will consider that there are total A, Ramesh and Ramesh. Total 3 words or tokens are there. Okay. So is it true? No, this is not true because both are same. So we need to use any technique to normalize them. So how we can normalize? Since it's a textual data, so either we can do the uppercase or we can do the lowercase. Okay, uppercase and lowercase. So by doing by changing it to lowercase or uppercase, we can achieve our goal. So text moving on to next topic, that is stopwords. So before that, let me just erase them all. So what is stopwords? So in English there are so many helping verbs. Okay, helping verbs or words which are not relevant, or if we say in terms of gathering the information, let's say he is a good boy. Okay, so if we see there are total 1 2 3 4 5 words are there. However, these two, if we remove them, still we can get the information that he good boy. That means we are talking about uh, a boy who is good in nature. So we can remove them off. Okay, because if we keep them, what will happen? Since these words is, are, am, the, not, was, have, had. Okay, they are helping. They are helping verb, and they are not exactly useful to extract the information. So what we can do, we can remove them off. So by removing them, we can lower the vocabulary size. So since it's a one sentence, now imagine if you have like this much big data corpus or data, then in that case what will happen? There will be a chance that the is coming 10 lakh times the is coming. Okay, so every time it will come, but it is not impacting your result, so we can remove them off. So there are a couple of stop words that are predefined by the system, okay, or predefined by the packages. Once we will do the stop words removal, we will see what are those and how we can remove them. Okay, and you can also create your custom stop words. Okay, let's suppose you are working for an organization or things like that, or for any college or any university, for any org. Okay, so since you know there are a couple of words that are not necessary for them. Okay, so those are specific words. Let's suppose someone working in Google. Okay, and the review has every time Google is written there. Okay, so it's a stop words because they know that this data is for Google only. So why to keep Google? So they can remove the stop words. So this way we can reduce the vocabulary, we can get the correct information, and we can remove the noise. So moving on to the next topic, punctuation. So we all know, like whenever we are writing any sentences, or we divide two sentences with the help of period, so often we use hyphen, we use slash, we use at the rate. Okay, so these are nothing but these are punctuations. Okay, so these are also kind of noise to us, so we can also remove them off. We will see how we can remove it once we will do the hands-on. Similarly, there are emails, URL IDs. So these are also a kind of redundant noise data. So we can also remove them with the help of regex by writing functions. So once we will go into Jupyter Notebook, we will look into that. Similarly, we can remove the numbers. By doing so, we can create a smaller corpus, or we can remove the noise. So sometime often whenever we are writing anything, what we do, we write something like ram space 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 is space space is a good boy, space space space, then period. Okay, so when your computer will process it, what it will take, that ram is a character, then space is one character, then again space is one character, space is one character. So by doing this, instead of three spaces, we can go with one space only. So with the help of white space removal, we can remove them. Similarly, when our text is written in another encoder, okay, let's say UTF-8, okay, or any other text is encoded in some other encoder. Okay, so what happens that, let's say there is a special character A, this is coming, okay, which is not necessary, or which is unknown to ASCII. So since we are dealing here with English character only, and in our computer, we follow the ASCII. So we can normalize the text to ASCII, and by doing so, we can remove those special characters. Similarly, we can do stemming, we can do lemmatization, we can do text vectorization. So what are these things? We will take separately one by one. So now let's move into the next slide. So what is stemming? Stemming is a process of removing suffix from a word to convert it to its root form. For example, let's say you are writing runs. Okay, let's take the same example. So in runs, its actual root form, the root of this word is run. Okay, and it's a another form of it, it's an another verb form it. Okay, so this is a suffix to it. So with the help of stemming, we can drop this off, and we can convert it into a run. Okay, so by removing the suffix, we can change the word to its root form. Okay, sometime it has been seen that stemming fails. So let's see the example. Let's suppose you are writing running. Okay, so when you change it to its root form with the help of stemming, what it will do, it will say run, because ing is a suffix to it. Okay, so it will remove it, and your word will become run, which is wrong. The correct form is run. Okay, so sometime it fails, but it has been seen that stemming, since stemming is not a complex process, so it's fast in nature. So whenever our data is something like that, we can go ahead with some of the we can go ahead with some of the errors, or with some of the noise, then stemming is a good operation to perform. Let me remove it. So yeah, moving on to the next slide. So similar to the stemming, there is one more process, lemmatization. So lemmatization is a process of converting a word to its root form with the help of lexicons. Okay, with the help of lexicons, what they can do, they can convert the words to its root form. For example, let's say if you write eaten, okay, so what it will do, it will change it to eat. Okay, or if you write running, so last time we saw that we were feeling, but since lemmatization use lexical rules, okay, so it uses grammar, so which makes it a complex operation to do, but it gives you a correct result, so it will change it to run, not run. Okay, so what we understood from these lemmatization and stemming, lemmatization is slow in nature, but and stemming is fast. However, it is accurate, but it is less accurate. Okay, so based on the use case and based on the data, we can take a decision and we can choose a appropriate operation to remove the to perform the stemming or lemmatization. Let me remove it. Now text vectorization. So since we know any machine learning or any deep learning model, okay, so they need the input to be in numerical. Okay, they need only numerical data. Okay, they cannot they cannot work with text data. Okay, so if we want to apply NLP and we want to extract the information, so for that what we need to do, we need to transform. Okay, so if we want to perform it, then first we will need to transform it. Okay, we need to transform it to numbers. Okay, so this process is known as text vectorization. So we are creating vectors of the text. So there are various text vectorization techniques are available in the market. Some of them are, let's say, bag of words, TF-IDF, word embeddings, and one hot encoding. Okay, so like one hot, okay, one hot encoding. So what happens that let's say in bag of words, we have what we can understand that as the name suggests, there is a bag and all the words, let's say this is a bag. Okay, so all the words will be converted into tokens, and those tokens will get some numbers. Let's say this will get 0, this will get 1, this will get 2, and this will get 3. Similarly, there is one more. This is a car. Okay, so this will get 0 because these two are same. This will get 1, this will get 2, but this will get 4. Okay, so when we apply bag of words, okay, and we create the vector for, let's say this is t1 and this is t2. So for t1 your vectors will be 0, 1, 2, 3. Okay, so this is your vector for t1. For t2 this will become 0, 1, 2, 4, since it has car, not bag. So this way we can convert them into numbers and then we can apply the machine learning. Similarly, what TF-IDF does, TF-IDF stands for term frequency inverse document frequency. We are not going to cover more detail about TF-IDF and word embeddings in this course. If you want to know about text vectorization, I would encourage you. You can go to the Google. You can go to the Great Learning Academy, and from there you can read about what is TF-IDF, how it works, what is word embedding, what is bag of words. So I'll just give you a basic understanding about what TF-IDF does. TF-IDF also converts the word into vectors, but it gives term frequency inverse document frequency. So in a nutshell, if we try to understand it, what it does, it converts low frequency documents, or the document whose counts are less will get higher precedence in TF-IDF. Okay, and those whose frequencies are higher will get lower precedence. Okay. Similarly, in word embedding is a advanced form of vectorization in which what we do, we provide the words, we convert the words into vectors, and we provide the features to them. Okay, so based on the features, we can segregate the words, or we can find the similarity between the words with the help of word embedding. So now let's come to what is Textblob. So what is Textblob? Textblob is an open source Python library which is used for ML activities like lemmatization, stemming, tokenization, noun phrase extraction, POS tagging, n-grams, and sentiment analysis. So what is n-grams? Since we didn't discuss about it, so let's now take an example to understand it. Let's say this course is about NLP and text blob. Okay, so what n-grams stands for? N-grams are, like, for example, let's say unigram. Okay, so unigram will get the tokens like this course is, similarly it will get text blob, okay, into a list. Similarly, bigram, or so what bigram will do, bigram will take the 2. Your window size from 1, it will change to 2. So now your window size is 2. This course will become 1 word. Course is will become 2. Similarly, and text blob will become third. Okay, so this will become second, this will become this, and then this will become this, then NLP and this, then this text blob and text blob. Okay, so this way we can create unigram, bigram, trigram, quadgram. So how many number of grams we want to extract, we can get that. And with those n grams, what we can do, we can get the phrase. For example, this course NLP and NLP text blob. Okay, so this way we can extract the information in terms of phrases. So this way it helps us in getting the phrase from the sentence. Let me remove it. So text blob is faster than NLP. However, they do not provide the functionality of vectorization and dependency parsing. Like we discussed in the previous slide, what is text vectorization? But these features are not available with text blob. So text classification, sentiment analysis, these kind of activities we can do with the help of text blob. So let me clear it. So how you can install text blob? So If you have Python, what you can do, you can install it with the help of this command pip install textblob. So once you do this, it will take more than 2 or 4 minutes. Hardly it will take 5 minutes based on the speed of your internet and all. It will get installed into your system, and then you can import textblob, and then you can do all the activities, functionalities of textblob. So for this, let's jump into Jypyter notebook and see you there. Now we have our Jypyter notebook open. So for this exercise, we are using Jypyter notebook and Anaconda. So if you don't have Jypyter notebook and Anaconda installed, I would highly encourage you to install them. Or if you have any difficulty, you can go through the videos of Great Learning. They have provided videos for how you can install and how you can run your programs on Jypyter Notebook with the help of Anaconda environment. So now let's get started. So we have discussed what is NLP. We have also discussed what is TextBlob and what are the kind of activities we can perform with the help of TextBlob. So without wasting any time, let's get started. This is the official website. You can go there and you can read about it, and you will find so many information about TextBlob. You will see examples how you can use them. So I will also encourage you to go through the documentations of TextBlob. So in order to install TextBlob, you need to have NLTK in your system. You need to have TextBlob. So pip install NLTK, pip install TextBlob. So since I have these installed, so I'm not going to do anything. So then what you can do, you can just write import NLTK and then NLTK dot download. In that you can write popular. Okay, so once you do that, what it will do, it will download popular corpus for natural language processing, and which will help you in going forward performing any activities in natural language processing with the help of NLTK. So once you download that, then you can also download this average perceptron tagger. Okay, this helps in doing the tagging task. Okay, so you can also download it. So in this session, what are the functionalities we will be looking into this video? We will be looking into what is language detection, what is word correction, how you can count the word or get the frequency of the words, then phrase extraction, then POS tagging, what is tokenization, popular pluralization of words using TextBlob, lemmatizations in TextBlob, and n-grams in TextBlob. So what is language detection? Okay, so with the help of Google Translate, what this TextBlob does, TextBlob takes your input, it hits the Google API, Google Translate API, and then from that Google Translate API, it gets an response, translated text, and that text it reflects in your system. If you don't know about APIs, how APIs works, how you can hit an API, so these things you can see in the video of Great Learning. They have also a video on APIs, so you can go and watch them. But for this course, we don't need to have API, or we don't need to hit any API. But for the sake of understanding how TextBlob works, we just wanted to give you the information. So let's suppose we have a text. Hey John, how are you? So first we will detect what is the language, or in which language this text is. Similarly, then we will convert it into Spanish. Okay. So for different language, they have extensions. Let's say let's execute it. To execute it, we will press Shift plus Enter. So once you press Shift plus Enter, it will take some time, and then you will see detected language is English, that is EN. Input text in Spanish. Hola, I'm not good at Spanish, so I'm not going to pronounce them. But yeah, this way we can translate the sentence into from English to Spanish. So now, when you there is a disclaimer or there is a note. So when you will do this text blob and you try to detect the language or try to translate the language, what will happen? You will get an error 404. Okay, why this is happening? Because recently Google have changed their API address. Okay, and which is not updated till now in text blobs API. Okay, I think in their function they will update in some other some time. Okay, but for now what we can do, you can change that. Okay, you need to go to your C user, then whatever is your username, then anaconda tree, then your environment name. Like let's say our environment name for this is Python. Okay, so we'll go to Python, then lib, then side packages, then text blob. In that you will find translate.py. In that translate.py, just copy this URL equals to this text and just paste it instead of the other URL, and you will be able to execute your code. So yeah, let's move on to our next thing. What is spelling correction? So what happens that whenever we write anything in any platform, due to typo or something like that, we do commit we commit mistakes. So how we can correct them? Okay, so sometime for a programmer, it's a difficult task to read each and every words. Okay, so what textblob does? Textblob provides you a feature to use a text blob and to convert the wrong word into a correct word. Okay, so it uses lexical rules to do so. We are not going to discuss those rules in a detail, how they can do the spelling correction. So I'll just execute it. So first we will import from text blob, import text blob. So we are from text blob, we are importing this function text blob, then executing it. Now let's print the text. ABCD corp ALAYS values, I think it's their employees. Okay, but the words are written in a wrong. Okay, so we will create an object of this. Okay, we will pass this text into this text blob and we will create a blob. Okay, so if you print this blob, let me print this for you. We'll create a new cell, blob. So text blob, this will give you the input. So blob dot correct, the correct as the function to do the spelling correction. So you will see ABCD for this corp is missing now. Always values their employees. Okay, so we can see sometimes some of the words are getting misplaced, but we see few words are getting corrected as well. Okay, let's use has. Okay, if you use smaller text, I'll give you a hint. If you use a smaller text, you will get the output correct, but if you provide a long string, it will not give you a good result. Okay, since someone has written UR instead of your, but it will convert it into OR, which is wrong. So sometime it is correct, sometime it is wrong. So based on the use case and based on the incorrection in the spelling of the words, you can apply it. Okay, so now let's see word count. So in any machine learning, we need to identify the variability. We need to know what is the variability of the documents or what is the variability of the data. So in terms of text data, it is very important to know the frequency. If the words have no frequency, Let's suppose you have 50,000 words and those words have no frequency. They are only called once. So it's a difficult for the machine, because what will happen, your this uh, the text vector, the vector will become very sparse. It will have zeros more as compared to ones. Okay, so in that case it will be very difficult for machine to understand the text, understand the patterns, and then do the classification, do the recommendation, and things like that, whatever you want to achieve. So it will become very difficult. So you need to know whether the text has the frequency or not. So the counting the frequency of words is very important. So for now, let's take an example. So let's take this word count. If you want to count the analyze, let me correct it out. Analyze, what is the count of sentiment? Sentiment count is 0. But if you see the sentiment in lower, it has a count of 3. So whenever you are searching a word with uppercase, see here we are writing in uppercase sentiment, sentiment twice, sentiment 3 times. Okay, if you see we have sentiment 3 times. But when you search this term, the sentiment with starting with capital, okay, it will throw a 0. But if you use this, it will give you 3. Similarly, if you use analysis, we know analysis frequency of analysis is 1, but still if you do it with the uppercase, you will get a 0 count. Okay, so be mindful whenever you are counting the word frequency, you need to provide it in lowercase. Okay, so now let's do POS tagging. So let's suppose you have a word, my name is Adam. I like to read about natural NLP and I work at ABCD Corporation. See, my, it's a preposition, name is noun, it's a verb, it's preposition, it's VBP, it's to, it's verb. So there are so many POS present here. Okay. Okay, now we got that. Okay, from any word we can extract the POS. Okay, but what I will do with those POS? Okay, let's suppose I know that. Okay, it's a noun, it's a pronoun, it's a verb, it's a adverb, adjective. I know each and everything, but how it will useful in my use case? Okay, now let's suppose you are you are doing some review sentiments. Okay, review sentiment analysis. Okay, and in that you will find that prepositions are not making any sense. Okay, or verbs are not making any sense. For example, I'm not going into the little understanding of that whether it the process is right or wrong, because any process is right or wrong is based on the data set. Until or unless you don't have the data set, you cannot say that this process is right or this process is wrong. But what we can do, we can understand that, okay, whatever I am doing is making sense to me or not. Okay, so we are just looking into example hypothetically. So let's say I want to remove this VBP. Okay, I want to remove this POS. I don't want this POS in my sentence. Okay, and if any word is there with this POS, I'll remove that word. Okay, so how we can do this? So I'll use forward loop for I in text dot tags. If VP not in I of 1. Okay, so let's execute it one by one. Print I. Okay, so I'll just remove them. If you print, you will see this. Okay, next what we are doing, if VBP not in I of 1, this is I, Okay, I of 1 is this, I is this, I of 0 is this, I of 1 is NN, I of this is this, VBZ is I of 1. Okay, so if this is not there, what we will do, we will update this new tuple list. Okay, so I'll just execute it. Now if you see, we have all those tuples into the list. Okay, now I want to join those sentences, so I'll use join. And now you see, my name is Adam, I do read and about NLP, I at Adam ABCD Corp. Okay, no matter what, this thing is like helping us in understanding, or is it making sense, this example or not. But what our intention was, or what our intention is here, to just see how we can remove a particular POS and how it will help me in cleaning my data. So now moving on to next thing, what is tokenization? So before that, what is corpus or corpora? Corpus is nothing but it's a collection of text data. So in terms of NLP, like we say dataset, in any machine learning thing, we say corpus in terms of natural language processing. Okay. So your corpus may be of one language, or it may be a combination of multiple languages. Okay, that is not a concern, but a corpus will contain text data. Okay, so now the next term which comes is token. We have discussed earlier also what is token and all. We discussed that we will convert the word into tokens. So token is nothing but a total number of words in a text. Okay, so what token is? Token is smallest unit of a sentence. For example, this is a book, so this is a this token is another token, another token, book, another token. Okay, so tokenization we can do with various things. Let's suppose if you want to, for example, ABC underscore 123 underscore DFGA. So you want to tokenize the text with the help of underscore, then your terms will become ABC is one token, 123 is another token, DEFG is another token. Or if you want to perform with the help of space, you can keep the normal space and then you can get the tokenization done. So now let's see how you can how we can do the tokenization uh, 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 in Textblob. Okay, so this is our text. We'll create a blob object of it. Okay, and then corpus.word. This is it. So now we have the tokenization on the basis of words. Okay, let's say there are 40 words. Tokenization we can do on the basis of sentence also. So on the sentence level, let's see, there are 3 sentences. Okay, so this way we can do tokenization at particular character level, or at particular spatial character level, or at the level of sentence. Okay, so what is pluralization of words, and how we can do it with Textblob? So now for that we will use the function word. From Textblob, import word. Then we will pass the words or the string to this function word, and we are storing the result into w small, then w small dot pluralize. So when you do this, becomes platforms. So but if you do the pluralization of platforms, let's see what will happen. It will add one more s to that. Okay, that is wrong. Okay, so now let's do one more thing. If our POS is NN, okay, what we will do, we will pluralize the word. Okay, so we will pluralize that particular word. So let's see. So our great learning is a great platform. So this become platforms to learn data science. So science becomes sciences. Okay. So which is not correct word. It helps community. So communities, that is right. But etc. will become ETCs. Okay. So this way we can do this. But yeah, we will have to be mindful whenever we are performing any activities in text, whether that will make any sense to it or not, that we need to check. So now let's see how we can do the lemmatization. So for lemmatization, we will create a object of this thing. We will create a Textblob object, and that from that we will create the unique tokens of it. Okay, and then we will do the word dot lemmatize. Okay, and word dot stem to perform the lemmatization and stemming. So now let's execute it. So when we execute it, we will see great learning. Great lemmatization is great, stemming is great. So learning, lemmatization is learning, stem is learned. Okay. Similarly, when we provide a word, okay, and we are lemmatizing it as terms of noun, you will see it's a learning. Since great learning is a name, so we are calling it as a noun. But if it is verb, how it will do? It will treat it as a verb. So it will change it to its base form, that is learn. Okay, like peoples. So it will change it to into people. Okay. So now let's do how we can do the n-grams. Okay. So we have our blob ready. So blob dot n-grams, where n is 1. Let's see. All the words are unique tokens. Okay. So unigrams. Now let's do the second one. Great learning. Learning is a. This way we are creating 2 grams. If we provide 3, it will become trigram. 4, then quadgram. Okay. So yeah, this way these are the functions which we can perform with the help of Textblob. Now let's move on to our next topic, that is sentiment analysis on Textblob. So for that, let's jump into our Jypyter notebook. For this example or for this exercise, the sentiment analysis on Textblob, we will be using the dataset, which is IMDb dataset sentiment analysis in CSV format. You can get this dataset from kaggle.com. You just use this link, kaggle.com/Colombian slash IMDb dataset analysis in CSV format. You will get that dataset. Okay. So now let's execute it. So now first here for this exercise, we are using a couple of packages like pandas, textblob, NLTK, RE package. Then we are using Spacey. If you want to know about Spacey, you can check the great learning links for that. Okay, and you will find great tutorials for that. Okay, so in Textblob, the format or the way we can find out any sentiment of a text is with the help of Textblob, then providing the text inside this brackets, then dot sentiment. Okay, so when you do this, you will get 2 things. One is polarity and the another one is subjectivity. Similarly, you execute this and then you execute the third one. Okay, so now if you see, you are getting polarity. He is a very good boy. Okay, so it's a polarity. Polarity means what is, whether it's a positive one, it's a negative one. Okay, so it ranges from -1 to 1. Okay, on the other hand, subjectivity ranges from 0 to 1. Okay, so what does polarity gives you? Polarity gives you what is the sentiment of that sentence. Okay, and what subjectivity gives you? Subjectivity gives you whether it's an opinion or not. Okay, if it's an opinion, then the subjectivity score will be more closer to 1. If it's a positive, it will be more towards 1 in the terms of polarity also. In terms of polarity, if a text is positive, it will be towards 1. If it's negative, it will be more towards near -1. On the other hand, subjectivity provides you whether it's an opinion or not. If it's an opinion, then your subjectivity score will be higher. And if it is not an opinion, your subjectivity score will be lower. He is a very good boy. That means there are so many people praises this boy, okay, or praised this boy. That means it's an opinion from a group. Okay, and he is a good boy. That means it's the sentiment is positive and it's an uh, opinion from people, so that's why its subjectivity score is higher. He is not a good boy, so your polarity is like -0.35. That means it's a negative sentence, but its a subjectivity is 0.60. That means it's an opinion from people. Let's move on to the next sentence. That is, everybody says this man is poor. So polarity is again negative because they are saying that this man is poor. So it's a negative sentence. On the other hand, the subjectivity score is higher. That means there are so many people. Since it is written everybody says, that means it's an opinion. So your subjectivity score is higher. So now for this, let's load the data. So for this, we will be using pd.readcsv to load a CSV file. So let's execute it. Now we have our data. Now we will be using, since it's a 40,000 data, and we will be lowering this data to 5,000. So lower that. So now we will be uh, training the data, getting the data. So now we have 10,000 data. Here there are two labels, 0 and 1. 0 stands for negative, 1 stands for positive. So for data pre-processing, the first step is to check whether the your sentence, whether the text has null values or not. So for that, we will use train.isNull.sum. So this is our train data. We'll apply that data. So we see that there is no null values present here. Okay. So then we will use NumPy. Okay. And we will use regex here to replace if there is a space. Okay. So what happens in NLP in text is that, let's say your text is something like that, then this is space, and if it is a value, then that will not be considered as a null value. But since it's a blank value, so for us it is not making any sense. We need to remove them off. Okay, so we can do this uh, with the help of this regex function. So let's drop them off if there is anything. So how we can remove skip sequence? Okay, so \t, \n, \r, these are nothing but these are space sequence characters. Okay, we don't need them. So in text, when the text getting encoded, these are added to the text. So we need to remove them. So we will use this. So we have removed them. Again, we will check that. Okay, so this is our text data. Now what we will do, we will remove the non-ASCII words. For that, we will use your text.str.encode ASCII, and rest you can ignore. Then how you will decode? You will decode it as ASCII. So this way we can remove that. Similarly, we can remove the punctuations. Okay. So before we go into that, let's see what is punctuation. Okay. Let me just create a space for you. Import string, then we'll use. So these are nothing but these are punctuations. Okay. So for that, we will write a function, remove punctuation. Inside that, we are importing a package. Then we are using a for loop. And if punctuation is there, we are replacing with no space. Okay. And then we will apply this function here to a Jypyter notebook. Now it is executed. Now let's see how train data looks. So this is our train data. So the data is same, but we have removed the uh, characters. Like for example, Mr. Lincoln. Okay. See, Mr. Lincoln is, the period is now removed. Okay. So we discussed the stop words. So these are some of the stop words which are famous stop words, and we can remove them off. Okay. So we will remove them off, but since we are doing a sentiment analysis, okay, and just take an example. He is not a good boy and he is a good boy. Okay. And if we remove not from that, let's suppose our text is he is not a good boy. Okay. What will happen? The sentence will get changed. Since we were saying this is a bad boy, now he is a good. So we need to take care of these kind of a thing, and these stop words, like I mentioned, is a use case dependent. Okay, so you need to look into your use case to identify how you can remove the stop words and what are the stop words you need to remove. Okay, so we will remove this from this stop word list. Okay, not and no. Okay, now we will create a function for that. Okay, it's a pretty straightforward function. So we will execute it. Now it will take some time. Now execute it. Train. So now if you see, there are no stop words here. Earlier, if you see, I, like 8704, I have. Okay. So if you see, never, I have is removed. Okay. Now we will remove the special characters. So we will regex, use regex for that. We will remove HTML characters. Sometimes we get URLs in our text, so we can remove those URLs with the help of RE package. So we'll remove it. Next, we will remove the numbers or integer from the text. So now we have removed it. Now we will remove alphanumeric character. Let's suppose some ID is there, SK012397J6, or someone's PAN card number is given. So we don't need those numbers. So we need to remove those alphanumeric characters. So with this function, we can remove it. We will create a, first we will identify that words, okay, the digits. Then in that digits, we will remove the string and digit. If string like alphabets and numbers both are present in a text, we will remove that with a space. Okay, let's execute it. So now if you see, our text is clean. Okay, so the next step which we are going to do here is we will be applying lemmatization. Now our lemmatization is done. So we are all good with all the pre-processing of the data. So now let's use the uh, textblob sentiment function to get the sentiment from the sentence. So this is our sentiment. We are storing the sentiment into a column known as sentiment, and for that we will be using train text. We will be applying that function with the help of lambda. So we will use that, suppose we are that text, each text will get into tweet, and this tweet will go into the text blob, and then we will get the sentiment from it. So now let's execute it. This will take some time, so we'll need to be patient for that. So I'll just wait for that to execute. So now this is executed. Now if you see train, so what will happen for that, for all the text, we will get sentiment, okay, and we will get a tuple, okay. One is like we discussed earlier, polarity, and another one is our mm, uh, one we will get this polarity, and another one we will get specificity, okay, subjectivity, sorry for that. We will get the next term as subjectivity and polarity. So now we have the list of that. So what we will be doing, we will be storing these values into a list, okay. So now let's execute it, okay, and we will create a new data frame known as df1, okay. So now let's see how our df1 looks like. df1, so if you see, polarity is a one column and subjectivity is another column, and then we will do the concatenation of train with df1. So now we have that, and now we will remove the sentiment, okay, and we will use the log function to, if the polarity is greater than or equals to 0.03, we will consider it as a positive and we will store it into a new column known as sentiment. If it is lesser than this, we will store it as into a sentiment as a negative. So now let's see, this is our polarity, this is subjectivity, and our sentiment. So now we can label them. If your label is 1, sentiment label will become 1. If your label is 0, sentiment label will become 0. So let's execute it. So we have that sentiment label, and we have sentiment, and we have subjectivity, we have polarity. So this way we can perform sentiment analysis using Textblob. Now we are at our end of the syllabus for this course of Textblob. So now let's recapitulate whatever we have covered in this course. So we discussed what is NLP. We also discussed some of the NLP examples in our real life. Okay, how NLP can be helpful in our life. Then we discussed what are the NLP challenges, data preprocessing in preprocessing in NLP. We also discussed about what is text blob, uh, how to install text blob. Okay, we got that pip pip install text blob. Then we also discussed functionalities of text blob. Okay, so we got to know about what are the text blobs functions, how we can perform those functions in Python. We also did hands-on on that. Okay, sorry, we did hands-on on that as well. We also see how we can use text blob for sentiment analysis. Okay, so I hope you enjoyed this course, and you got to learn about how you can apply Textblob and how you can make your data preprocessing in NLP easily. So I hope you had a great session and you enjoyed this session. So with this, I'm going to wrap up this session. So yeah, that's about it. Thank you.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.